Hello out there, and welcome to our lesson on Venn diagrams with three sets. This will be a good continuation of the previous lesson, as we're really not going to be doing anything new. We're still going to be using the three operations that we've discussed. The only difference is, instead of just two sets in our Venn diagram, we could possibly have three. So we have to be able to distinguish between the different regions that are created when we have three overlapping sets in our Venn diagram. Now, just to recap, we talked about three operations. Okay, we talked about something like this. When we see our set, in this case set A with the little exponent of C, or we could see A with the prime notation, or A with the bar over it, all three of those would be asking us to find the complement of that set. And the complement of the set, remember, means what elements are not in that set, or if we have all the elements that are in set A, what's everything else that's in the universal set but not in A. Okay. We also talked about this symbol, the one that looks like an upside down U. That is the symbol for the intersection of sets. And when we're looking for the elements in the intersection of sets, what we want is what elements are in one set and the other at the same time. So what elements do our sets have in common will be found in their intersection. And then we also talked about the U as being the union of the sets. And the union of the sets means what elements are in one set or the other, which means to find that union, we would have to combine all of the elements from the sets. Okay? Now, when we're looking at a Venn diagram with three overlapping sets, like this guy here, what we should notice are there are 8 different regions that are created. Okay, so I'm just going to number these off. Let's call this region 1, and 2, and 3, 4, 5, 6, 7, and then outside of our circles, region 8. So if we were placing elements into this Venn diagram, there are 8 different places where the elements could go. So we have to understand where the elements would go, what each region of what each of these 8 regions represents for the Venn diagram. So for example, region 1. If we're talking about region 1, this area right here, what kinds of elements would go into region 1? Well, those would be elements that are part of set A only, right? They're in set A, they're not in B at all, they're not in C at all, and clearly they're not outside of the circles. These would be elements that would go in a region or in set A only. So that region is for elements in A only. So A only, we're going to put a little 1 right there, region 1. And then similarly, in this area, we would have elements that are in B only, and then in this area, we would have elements that are in C only. Okay? So, let's see, region 3 is for B only, and then region 7 is for C only. Okay? Now, if we were looking for elements to go into this region here, region 4, that would be elements that are in common to A and C only. Now, if I said A and C, technically A and C overlaps in this entire area, but if I want only A and C, then I'm restricted to just this region 4. Okay, so that's A and C only. Region 4 is A and C only, and then similarly, this space, this region, would be A and B only, and then this region would be B and C only. Okay, so region 2 is for A and B only, and region 6 was for B and C only. And then the 2 remaining regions, I think, are pretty straightforward. What's happening in region 5? What's happening here is that is the intersection for all 3 of the sets. That is where A and B and C all overlap. So elements in common to A, B, and C would have to go into region 5. And then lastly, in region 8, that's outside of our circles, right? Region 8, outside of our circles, any of this space out here would be elements that aren't in A, B, or C, but are in the universal set. So that would be region 8, elements that are in the universal set, but they aren't in A, B, or C. Okay? Now let's try to put this into practice. If we have to create a Venn diagram and we have three sets that overlap, how do we go about constructing this Venn diagram? As we did on that last example in the previous notes, if you recall, we started in the middle of the Venn diagram and then we work outward from there. So we start in the innermost overlap, which means we would start in this middle space here, and then we're going to work outward. So then we would look for the next pieces of overlap, right? These sections here, and then we would work out toward what would be in A only, what would be in B only, what would be in C only, and then whatever's left over is going to go outside of our three sets. Okay, so we're going to start in the middle, go to that next section of overlap, go into A, B, C only, and then outside of our circles. Okay, so let's try this out. Looking at our lists here, lists for A, B, and C, do we notice any elements that are in all three of the sets? Do you see anything that is in A and B and C? So it looks like S is in all three of those sets, and that's all. So we're going to put S in the middle. It belongs to all three groups. Now, as we use elements, we want to cross them off all of the lists to make sure that we're accounting for everything. So S has been placed in the middle. I'm going to cross S off of each of the lists, including the universal set. Okay, now we're going to work out to the next set of overlaps. So I'm going to look at what is in A and B. What's in common to A and B? So A and B both have R, and I think that's all that's in common to those two. So A and B, we're going to place R, and then let's cross R off of each of the lists. Now let's look for what's in common to A with C. A with C. So A and C, P and Q, T, U, nothing. Nothing in common there, which means this area of the Venn diagram is going to be left blank. Totally fine. Now I'm going to move over to B and C. Do they have anything in common? B and C. B and C both have T. B and C both have U. So I'm going to put T and U in that region. And now I'm going to cross T and U off of all of my lists. Okay, and now we can go out to the A only, B only, C only. And I can see that left over in A, we have P and Q. So P and Q, cross off P and Q. Nothing left over in B, which means B only section will be left blank. And then left over in C is the element V. So V will go there, V will get crossed off. Now the only two remaining elements, not in the sets, but in the universal, not in sets A, B, or C, but in the universal set are W and X. So we can put W and X outside of the circles. And there it is. Okay. Now, as I mentioned yesterday, I like to do these U-tries. If you're feeling confident in the material and you want to give this a shot, then feel free to pause the video and try out the next example. If not, no worries. Let's get this thing done here. So we're going to start in the middle. I want to see if there's anything in common to A, B, and C. So A, we've got evens, B, 1 through 7, C, 6 through 11. So it appears that 6 is on all three of those lists, and that's it. So we're going to put 6 in the middle, and then let's cross 6 off of all of our lists. Now let's look for anything in common to A and B. Let's see, A and B share 2, and they share 4, and that would be all. So in A and B only, we're going to put 2 and 4. And now let's cross 2 and 4 off of all of our lists. Now let's look at B and C. So I already used green. B and C share 7. And that is all. So B and C share 7. Let's put that in. And now let's cross 7 off of all of our lists. And then we need A and C. A and C share 8. A and C share 10, and that's that. So A and C, we're going to put in 8 and 10. And now let's cross 8 and 10 off of all of our lists. Alright, now left over in A we've got 12. Place that, cross it off. Left over in B we have 1, 3, and 5. So let's put in 1, 3, and 5. Cross them off. And then left over in C we have 9 and 11. Place those, cross those off. And now we can see that 13 is the only thing remaining on our universal set and not in sets A, B, or C, so 13 goes outside of the circles. Okay? Hopefully that's not too bad for you. It'll maybe take a little practice, but remember, start in the middle and then work your way outward. Okay? Alright, so on the back here, again, just some more practice of what we looked at in the previous lesson to make sure that we're okay with our set operations. So we have a picture, some overlapping sets, 3 overlapping sets, but already completed. We just gotta remember how to find complements, unions, and intersections. So number 1 says to find the complement of A. So the complement of A, I can see A. Here's my set A. Remember, the complement is what's not in A, what's everything else. So I can see not in A would be 10, 11, 12, 6, 8, and 5, and 7. So that's going to be the complement of A. So we're going to list this out, and remember, it doesn't matter the order that we put the elements. Now, if you're like a little OCD, that's okay, I understand, and you want to put them in order, totally fine. I'm just going to go left to right here. So we have 5, 7, 6, 8, 12, 10, and 11. Those would be the elements in that complement. Okay? Alright, let's look at the next one. Same concept, just different notation. This one is saying find the complement of B. So number 2 is the complement of B. Now I can see B, exactly what's in B, 4, 12, 10, and 11. So the complement is what is not in B. Not in B, 1, 2, 3, 9, 5, 7, and then 6 and 8. So let's see, we're going to say what's not in B is 1, 2, 3, 5, 7, 6, 8, and 9. Again, it doesn't have to be in order. Clearly I messed something up in there. We got 1, 2, 3, 5, 7, 6, 8, and 9. Good. Okay, I've got all 4, 5, 6, 7, 8 of those elements. Alright, number 3, same thing. Okay, we're looking for different notation, but same thing, complement of C. So let's get rid of all this. We have complement of C. So here's C. Complement of C is what's not in there. What is not in C is the 1, 2, 3, the 5, the 7, and the 10 and 11. So not in C, we have, again, the 1, 2, 3, 5, 7, 10, and 11. And there it is. Okay? Hopefully we're doing all right. Alright, let's go. Next guy. Remember that symbol? That symbol is asking you to find the intersection for A with B. That is, what is an A and B at the same time? So where is the overlap for A and B? So A and B overlap here. And the only thing in that intersection for A and B is 4. So this is just going to contain the element 4. Alright, that wasn't terrible. Number 5 says to find the union for C with B. So the union, the U there, says let's combine all of the elements that are in C or in B. So if I unite those two, I've got B, I've got C. If I combine all of those elements, then I need 4, 9, 6, 8, 12, 10, 11. All of those would be in the union. So we are looking at, again, they don't have to be in order. We've got the 9, the 4, the 12, the 10, 11, 6, and 8. And if it's really bothering you that those aren't in order, like I said, not a big deal. Put them in order. Okay? Now we got to be careful looking forward here, because the next few problems are asking us, well, at least the next one and then some down below, might be asking us to do multiple things. Okay? follow order of operations, which said start inside of the parentheses. So number 6 asks us to do two things. It says to find an intersection and a complement. Now, since the intersection is in the parentheses, that's what we have to look at first. So we want to find the intersection first, and then we'll deal with the complement. So the intersection for A with C. So A and C are intersecting here. That is what those two sets have in common. So in the intersection for A with C, we have 9 and 4. So now it says we don't want that, we want the complement of that. So the complement of that would be everything else. So everything else is the 1, 2, 3, 10, 11, 12, 6, 8, and 5, and 7. So we are looking at, again, the 1, 2, 3, 5, 7, 6, 8, 12, 10, and 11. Okay, and there it is. Now the next one, let's get rid of this. The next one is two operations but no parentheses, which means everything is happening simultaneously. So we are looking for, at the same time, what is in the intersection of A, B, and C, all at the same time. What is in the intersection of all three of those sets? So the intersection for all three of those sets, all three of those sets is happening right here. That is where all three intersect. So the only element in the intersection for all three at the same time is 4. So this is going to take us to element 4 once again. Alright, number 8 is kind of similar. No parentheses, even though it's two operations, it means we want these all to be happening at the same time. This time it is the union of all three. So I want to combine all three of those things at the same time. So if I was going to combine all three, A and B and C, all of these elements, if I united all of those, then I'm including all those elements. The only thing that's not going to go in would be the 5 and the 7 that are outside. So the only thing we're skipping is 5 and 7. So we go, let's see, 1, 2, 3, 9, 4, 12, 10, 11, 6, 8. This is the numbers 1 through 12 in there, but we're going to skip 5 and 7. So 1, 2, 3, 4, not 5, but we've got 6, not 7, 8, 9, 10, 11, and 12. Everything but 5 and 7 that were outside. Alright, now, here's where we're going to separate the weak from the strong here. No, I'm teasing. This is where it gets really tricky, okay? We've got multiple operations, we've got parentheses, so we have to be really careful and kind of piece this next thing out. It's asking us to do several things here. So it says we're going to take A, and then we're going to unite that with, well, two things have to happen here. We got to find a union for B and C, and then we have to find that complement. Okay? So we're going to start inside of the parentheses. So for my first step, I'm going to ignore this A, and I'm going to ignore this union. We're going to come back to that. My first step is to figure out, what do we have going on here? What is in the union of those two sets? So if I was to unite B with C, back to my picture here, if I unite B with C, then I want 10, 11, 4, 12, 9, 6, and 8. Okay? So we have in there 4, 9, 12. Okay, I need to write this a little bit better here. We have 4, 9, 12. What else do we have? 6 and 8. And 10 and 11. Okay, so that's what we have in that union. Now I'm going to find the complement for that union. Okay, so again, the complement for that union is what's not in that union. So everything else, which is the 1, 2, 3, and the 5 and the 7. So now we're looking at the complement of that union being, we said 1, 2, 3, 5, and 7. So 1, 2, 3, 5, and 7. Now I can unite that with A. And just so I can see it clearly, what elements do we have in A? Picture's getting all messy here. What elements do we have in A? We've got 1, 2, 3, 4, and 9. So 1, 2, 3, 4, and 9. 1, 2, 3, 4, and 9. Okay? So I pieced all that out, and now I can do the last thing, which is unite those two sets. So if I unite them, remember that means I want to combine everything that I've got. So if I combine everything I've got there, 1, 2, 3, 4, 9. 2, 3, 4, and 9. And now combine over here. I've got the 1, 2, 3, 4 already. I just need to add in the 5. What am I missing? Oh, I missed the 7. You're probably screaming at me. 7 goes in there too. So 1, 2, 3, 4, 9 we got. 1, 2, 3, 4 don't need to repeat, but we do have 5 and 7 to add into that mix. So 5 and 7. And there's that answer. Okay? Alright, last one is going to be similar in the level of difficulty. We are going to have to try to piece this out one thing at a time so that we don't mess anything up. So inside the parentheses first, then we'll handle the complement and then the intersection with B. Okay? So first, I want to know what's in the union of A with C. And actually, let me change colors so this doesn't run. So what's in the union with A and C? If I unite A with C, A with C, wow. A and C, if I unite that, then I've got 1, 2, 3, 4, 9, 6, 8, and 12. 1, 2, 3, 1, 2, 3, 4, 9, 6, 8, and 12. Okay. Too sloppy here. 1, 2, 3. 1, 2, 3, 4, 9, 12, 6, and 8. I believe that was. Let me just double check. 1, 2, 3, 4, 9, 12, 6, 8. Good. Okay. So that's the union for those two. Now I need to find the complement for that union, which means what's not in that union. So not in that union, everything else would be the 10, 11, and the 5 and 7. So that takes me to the 10, 11, 5, and 7. Okay? So that's this half of the problem. Now what we need to do is find the intersection. So this is here. Find the intersection with B. Okay? So I need to find the intersection with B, and B, let's identify from our picture. A big mess. B contains 4, 10, 11, and 12. 4, 10, 11, and 12. 4, 10, 11, and 12. Okay, so the last piece here is now to intersect these two, or find the intersection for these two groups, these two sets. So in the previous example, we united them, we combined them. Here, in the intersection, we want to know what do the two groups have in common. So what is the same on both lists? Well, both lists contain 10, and both lists contain 11. So those are the elements in their intersection. So our final answer here is going to contain the elements 10 and 11. Okay? And there it is. I know those last two are really challenging. Unfortunately, in the next lesson, we will get some more practice with those. In the meantime, I don't know what happened over here. In the meantime, just, work on the practice assignment that's in Canvas. And if you're struggling, like I say always, just reach out. Email, phone, drop into a conference, and I'll be happy to help you out. All right, guys, take care.